we start with some definitions. First of all, pi x denotes the number of primes not exceeding x. That is, pi x equals the number of primes less than equal to x. So which imply pi x tends to infinity as x tends to infinity. Another function is Mangoldt function. Defined by lambda of n equals log n 0 if n is equal to p power n for some p and m greater than equal to 1, 0 otherwise. Another function is Chebyshev function. Psi x and theta x. For x greater than 0, psi x is defined by summation and less than equal to x lambda of n. Here lambda is Mangoldt function. So by putting the value of lambda n, this may be written as for m equal to 1 to infinity p power m less than equal to x p power m, and here which may again be written as 1 to infinity x power 1 by m log p. So as you see that this summation runs only for primes and this sum is empty if x power 1 by m is less than 2, because there is no prime less than 2. So we will solve this by taking logarithm on both sides. 1 by m log x less than log 2, and this imply m is greater than log x by log 2, which may be further written as log x with base 2. So using these values, now we can define theta x equals summation p less than equal to x log of p, and this theta x is called Chebyshev theta function. So using Chebyshev theta function, we again define Chebyshev function psi x, which may be written as summation m less than equal to log base 2x x less than p less than equal to 1 by m log of p, and here putting the value of Chebyshev theta function. Now we are going to discuss corollary to Abel's identity, that is deduction of Euler summation formula. So for that, first of all define small a n equals 1 for all n greater than equal to 1. Then the relation between capital AX and small ax becomes n less than equal to x an summation n less than equal to x. So this is 1 for all n, it is 1, and when we open up this summation, this will comes out to be the greatest integer of x, the integral values of this summation, that is greatest integer of x. So by Abel's identity, so we write the formula first. That is, here we will put the value of capital AX. Wherever capital AX is, we will replace it with the greatest integer. So greatest integer of x, fx, greatest integer of y, fy, y2x, at, f dash t, dt. So which may further be written as summation y less than n less than equal to x. So the small a n is 1 now. This is fn, which is the left hand side of Euler summation formula, and on the right hand side we have fx, greatest integer of x, fy, greatest integer of y, and here we will write it as at is greatest integer of t. So we will write this as greatest integer of t. We will add t and subtract t to this, and we are going to separate greatest integer of t minus t and plus t. So it becomes y2x t minus greatest integer of t f dash t minus y2x t f dash t dt. So this integral can be easily solved by integration of by parts. So solving is fx, greatest integer of x, fy, greatest integer of y, y2x t minus greatest integer of t f dash t dt. So here we have negative, or already we have negative sign, so this is positive and this is also positive, minus, solving this by parts, first function, integration of second, limits y to x, derivative of first function, integration of second, dt. And which may be written as fx, greatest integer of x, fy, greatest integer of y, y2x t minus greatest integer of t f dash t dt, minus, so this becomes x fx plus y fy plus y2x ft dt. We just combine this with this and this with this, so it becomes y2x ft dt, y2x t minus greatest integer of t f dash t dt plus fx common, greatest integer of x minus x minus fy common, greatest integer of y minus y, which is Euler summation formula.